we need to find all x's, which are real numbers, so that the absolute value of x plus 1, this guy right here, is greater than 0, which means it's positive, okay, non-zero, okay, and it's also got to be less than some value delta. We don't know what delta is. We do know that delta is also greater than 0 because by transitivity, since 0 is less than or equal to x plus 1, the absolute value of that guy, which is less than delta, then clearly delta has to be greater than 0 as well. Okay, so how are we going to do this? Well, let's go ahead and get a sketch out. So let's draw that a little bit more evenly. Okay, so here we're looking for, remember, when we use distance, the distance between two objects, this is the distance between x2 and x1. So the distance between two real numbers, or two objects here, is given by the subtraction in the middle and the absolute values around it. We would like this to look like this. So let's go ahead and convert it. And that's fairly easily done. Okay, so we've got that. So what we're looking for here, this middle expression says we're discussing the distance between a real number x, okay, it's a real number over here, and another real number, negative 1, which is right here. So here's negative 1. Now x has got to fall somewhere around negative 1, right? Okay, because we're looking for the distance. But we know that their distance, the distance between x and negative 1, wherever x falls on this line, okay, its distance has to be less than some positive number, delta. So let's say that delta, I'm going to do it like this. Delta is a number, okay, such that if this was 0, delta would fall right here. Okay, so delta is a real number and we're going to associate a link with it. So if I take negative 1 and I add delta, okay, so I'll add delta, that will put me over here at negative 1 plus delta. For example, it's easier if you look at this with numbers. Let's say delta was equal to 3. Well, if delta was equal to 3, then this guy would be negative 1 plus 3, which would be positive 2. And that makes sense, because if you move this way 3, you'd end up at positive 2. So this guy clearly, whatever delta we pick, if delta was 3, or if delta was 10, or delta was pi, it doesn't matter. Whatever delta is, that'll move us this direction, and to get to this point, this actual point right here, okay, that point is negative 1 plus whatever that delta value is. Okay. Now to get to this point over here, if we add delta for this direction, we have to subtract delta for this direction. So this would be negative 1 minus delta. And of course, x has to fall somewhere on this interval. Now it can't actually get out to these endpoints because the distance between negative 1 and x has to be less than the delta value that goes out. So we're not going to include these endpoints. So x can be anywhere it wants in here. So we have to be careful. Okay, so I'll talk about the restriction in just a second because that comes here. So if x is anywhere between this guy and this guy, we can write it like this. Negative 1 minus delta is strictly less than x, which is also less than negative 1 plus delta. Or you could write it like this. Negative 1 minus delta, comma, negative 1 plus delta. And this is interval notation. Okay. Now, but we've neglected something here. We've neglected, like I said, we neglected this guy over here, this 0. What does that 0 say? That 0 says that the distance between x and negative 1 has to be positive. it can't be 0. It's got to be greater than 0. So what we're saying is the distance between x and -1 can't be 0. Well, what does that really mean? That really means that x cannot be equal to -1. So that's another restriction here that we don't have. Okay, so we have to add that guy in there. So if we look at this up here, we're really not quite right. We can use all of this, and we can use all of this for our x values, but we can't use that. So we really have an open circle there in the middle. This guy right here does not describe the open circle in the middle. So to get the open circle in the middle, we could do a couple things. Okay, we can set this up. We can say this and x cannot equal -1, or we can use interval notation, and the interval notation would be from -1 minus delta all the way up, all the way up to -1. So that's this interval right here, not including -1, because x can't be equal to -1. So remember, these intervals talk about what x is. Okay, so x is inside this interval. X is inside this interval. Now clearly this is not the right interval because of this issue over here. So we have to union this with -1 to -1 plus delta. What this is we have a left endpoint. If you draw a number line out, we have a left endpoint here at -1 minus delta. We don't include it. Then we go all the way up to, so here's -1. We go all the way up to -1, but we don't include that. And then we go from -1, again, we're not including -1, up to -1 plus delta. Just like that. Now let's go ahead and just check to see if our interval here works. Let's pick a value. Now, here's how you work this. So if you're at home right now and you're working through this problem and you're following along and you're like, man, I don't think I could do this on my own, the reason that you're getting confused is because we're using some variables. So you need to pick some actual numbers and play around with this. I'll do one. I think you should do a couple on your own. So I'm going to pick a delta value. Remember that because of our initial condition, delta has to be greater than 0. So let's pick a delta value that's greater than 0. Okay, so we'll do this down here in blue. So here's an example. So let's let delta, I don't know, I'm picking a random number here. Let's let delta equal 5. Okay, if delta was equal to 5, our original problem would be 0 is less than x minus -1, or x plus 1. Absolute value of that guy, which is less than 5. So let's think about all the x values that we can plug in here. So remember, this is equivalent so don't lose sight of the big picture here. We're trying to find every x value that works in this compound inequality. Yeah. So let's go ahead and look at, so my deltas look a lot like 5s, don't they here? I'll have to be careful on how I write them. Okay. So let's go ahead and start looking at this interval here. We've got two separate problems here. This is problem number 1 is 0 is less than or equal to x plus 1, and problem number 2 is absolute value of x plus 1 is less than 5. Okay, so let's look at the graph for this part right here. Well, this just says that x plus 1 has to be, the absolute value of it has to be greater than 0, which means that x can't be -1, because if x was equal to -1, watch what happens. 0 is less than -1 plus 1, so 0 is less than the absolute value of 0, so 0 is less than 0. But that's not true. 0 can't be less than 0. And this is starting to look like a face here. Let's see if you're still following along. Okay, so So we know that x can't be equal to 0, or x can't be equal to -1. So that's what this thing gives us. Now it gives us a little bit more. It says that x can be any other number except for -1. Okay, so what it says is if here's -1, x can be anything on this side, and x can be anything on this side. But both of these guys have to hold, part 1 and part 2 do. So let's look at part 2. I'll do that one in red. Okay, so part 2 is going to be in red. Now if 1 and 2 hold, we're going to look at where these guys overlap. So for 2, we're looking for all numbers that when you add 1 to it, you're still less than 5. Okay, so let's think about these guys. Every number that you could possibly add to 1, well, the biggest you can add is 4. Because 4 plus 1, that's clearly less than, 4, we can't use 4, right? Okay, but we can use everything up to 4, so I'll put a parenthesis there. Now let's look at the lowest we can go. What I mean is for this left on the number line we can go. And if I go all the way to -6, okay, -6 plus 1 is -5, and take the absolute value of that. I can't use -6, but I can use everything just to the other side of it. So I can use everything in here. So this is going to go from -6 to +4. It's around -1. And this guy over here says I can use everything in between. Now what I want is where these guys overlap. Because I have both of these have to hold, so it's like an AND problem. So where we overlap. So here's -1. We can't use that. Can't use -6, but we can use everything in between. Stop at -1, and we go all the way out to 4. So this one here says that x has to be on the interval -6 to -1 union -1 to 4. Now let's check if our answer from above works with that delta value. So here's what I mean. Remember, this was our answer. If we plug in a delta value of 5, do we get this same thing down here? Well, let's check. So if I plug in 5, that'll be -1 minus 5, comma -1, union -1, comma -1, plus 5. And if we simplify here, this guy right here is -6, and this guy right here is 4. And my 4 got small there, okay, because it's on the side of the screen. Okay, so you should go through, you should try it with another delta value. Pick something else out and make sure that it works.